Make sure your backpack is on the floor. It is not. All right, Jonathan, thank you for sitting and slant right off the bat. I really do appreciate it. I'm gonna have to get some payments out soon enough, but right now we need to get rolling because that was a little bit of time. And time is money. So, lesson 67, make sure that it's on the top. We are using prime factorization to reduce fractions. You know how to reduce fractions. Now, this is going to be another tool in your tool belt when you need to reduce a fraction. Bless you, Jamarion. Right now, our I can statement for the day is I can use prime factorization to reduce fractions. Say that with me, class. I can use prime factorization to reduce fractions. That is our goal for today. Please, we're going to say this one more time at the end, if I remember to do it. And please make sure that is a true statement. We're moving on. All right, only example for today. We're going to be doing one more extra one afterwards. But for right now, I need you to copy down 375 over, so as a fraction, 1,000. Nod your head if you remember this. Yesterday we used, was it the day before, where we used prime factorization in a factor tree, and we divided by prime numbers. Do you guys remember those lessons? Can you guys, like, right now point to the chart that tells you what's a prime and composite number in the classroom? Right. So what we're going to be doing today is those same process, but now we're using it in fractions. And you can only divide these numbers by a prime number. First of all, I'm going to draw nice and big. Make sure this is in your notes. First thing you're going to do is draw one big line for your numerator and denominator. Depending on the numbers, you might have a really long line. Some of them you might have really short lines. But you need one big line for your new fraction for prime numbers. First off, what can we divide 375 by that's a prime number? Because you can only use the prime numbers. So the white squares, not the blue squares. Starting with 375, Jonathan. You can start with 5. He knows he can start with 5 because it ends in 5. So you can do 5. You can do $x for times. Just like your answers for the other lesson, when you use a factor tree, your answers will look just like this, but just in fraction form. All right, so we got 5. Now, 375, class, please, what would 375 divided by 5 be? Thank you for the good catch. Please make sure you fix that quickly and quietly. Kingston? 71? Well, let's see here. 375 divided by 5. Can't go into 3. How many times, class? With a strong side of the hand, how many times can 5 go into 37? 3C. 7, because you get 35. Subtract that, you get 2. Drop down to 5. How many times can 5 go into 25? Asia? 5 times. We got 0. So our new number is 75. Can we reduce 75? By what? London, beers. You can divide it by 5 again. So I'm going to go back to my other page. I'm going to write down another 5. Back to here. Take 75 and divide it by 5. Okay, Jonathan, how many groups of 5 are in 7?
1.
Thank you for speaking loud and clear. You got 1. You subtract. You get 2. Drop down to 5. You have now 25. How many groups of 5 are in 25, Chastity? Yes, thank you for showing me with your fingers, because there's more than one way to convey a numeral. You get 25. 0. So now we have 15. Is that a prime number? No. What can we divide 15 by? London. You can divide it by 5. So now I have to go back to my other page. I can divide it by 5 again. So 5. I'm going to clear this off. So now we take 15 divided by 5. How many groups of 5 are in 15? Show me with your fingers. You guys are all doing super stellar right now. I got Jonathan, Kingston, London, Antoine, Amari. If you don't know, give in the peer pressure. Miara. Got it this time. Reese, Jamarian. Yes, it is 3. Is 3 a prime or composite number? Amari. Prime or composite? It is prime. So that means I can circle it. We're done. Go back to here. I got 5 times 5 times 5 times 3. A lot of work, right? Now we got to do the same thing for 1,000. What can we divide it by first? That is a prime number on the prime chart up there. Also, maybe you guys want to make your own. That's fine. Go ahead. Keep it in your math book. Just can't use it on tests. But that's fine. You can use it for your homework. There's also one in the back of your book. Kingston.
2.
You divide by 2. So first put down a 2. Let's go to our work page. Gotta get rid of this. 1,000 divided by 2. Can't go into 1. So I like to put an X. You can put a 0 there. That's fine. How many groups of 2 go into 10, Destiny? It is 5. Yes, thank you so much. Subtract. You got 0. We only have zeros left, so what can we put above each of those zeros right off the bat? Because we're both super geniuses and kind of lazy. Reese? You can put 2 zeros, correct. Remember, I am all for shortcuts in math. All right, so now we have 500. Is 500 a prime number? McKenna? You don't know? Is it prime or composite? I can't understand you. Your hands on your cheek. It is composite, yes. What can 500 be divided by? It has to be a prime number. Asia. It can be divided by 5. So let's go back to our page. We can write 5. All right? Not quite done yet. So we take 500 divided by 5. How many groups of 5 are in 5? Jamarian. There is one group. Thank you so much. We got 5 minus 5. We got 0. Since there's only zeros left, what can we just do because we're super smart and kind of lazy? I am lazy. I don't know about you. Mari? You can add 2 zeros. So now we have 100. Nod your head, yes or no. Yes for prime. No for composite. It is not prime. So we got to keep going. What can we divide 100 by? Antoine.
10.
10's not a prime number, though. Oh. Destiny? You divide by 5. Now, you know the process. We got to go back, add a 5. Because we got to keep going until we get a prime number. Okay, I'm going to delete all this stuff because my handwriting's too big. 100 divided by 5. How many groups of 5 are in 1? Well, none. How many groups of 5 are in 10? London? Yes, thank you so much. 10 minus 10. All right, because we're super late. I'm lazy. What can we just put at the end of this? Asia? You put a 0. So now we have 20. Check the chart. Are we done? Is it prime? No. Man. So much work. What can 2 to be divided by? That's a prime number. McKenna? Right. 2. So, I almost forgot. Mr. Sievert almost forgot. He almost forgot to go back and write down the 2. So you got to make sure that you put down the 2 first so you don't get lost. All right. Now we can go back and do 20 divided by 2. Okay. Destiny? Which one? Oh, did I write? Let's see. Nope, we got 2, 5. We'll check it in the end. Let's check it at the end. I'll show you how to check it at the end. Let's keep going. Let's keep the move going. So I'm pretty sure I got it right. Anyway, 20 divided by 2. Kamari? 10. All right. 10 is not a composite number. Or not a prime number. We talked about that already. What can you divide 10 by? Jemaya?
5.
You can divide by 5. So first of all, go back to the other page. Add a 5 times, because we don't have a prime number yet. So 10 divided by 5 can't go into 1. How many groups of 5 are there in 10? Show me with your fingers. Reese, show me with your fingers. How many groups of 5 are in 10? Len's got it. Miara's got it. Miara. Asia. Waiting on one person. Destiny, there is 2. Make sure your heads are up. I'm going to have to start giving deductions out for people because I've been seeing people with a lot of heads low. So we had a 2. Is that a prime number? Shake your head yes or no. It is a prime number. So we're at the end. All right. Destiny asked if there was a mistake. If we forgot a 5, if I forgot a 5, something happened. So right now, what I want you to do is take 2 times 5 times 5 times 2 times 5 times 2, multiply them all together, and see if you get 1,000. If you don't get 1,000, we made a mistake. I should see your pencils moving, because I doubt you can do it in your head. I can't do it in my head. I need to write it down. Yeah, 2 times 5 times 5 times 2 times 5 times 2. London, what'd you get? You got 1,000? Destiny, did you get 1,000? Did you get 1,000? Who else got 1,000? All right, we did it right. Awesome. Thank goodness. Because if we miss just one, it will throw our answers off massively. So Destiny, thank you for having us check that. That's very important. You have to start. Me and Miss Asima need to make one just chart for all of you guys. It's too much. Very too much. All right, I'm going to use red. Now, this is where we get to reducing. So remember, we started with a fraction. Our question was, we need to reduce this. This is how it works. We go 1 for 1. Because what happens if you have a same numerator and denominator? The fraction just becomes, Jonathan? Well, you cross it off, but what does it come? If you have 2 over 2, 3 over 3, 4 over 4, 5 over 5, 6 over 6, 7 over 8 over 8. Wow. McKenna? It just becomes 1. So that's what we're looking for here. And like Jonathan said, we're going to go 1 for 1. We're going to cross them off. So first of all, you see that there's a 5 up here. There's a 5 down here. You put them on top, you get 1. So you cross them off and just write 1. All right, we got a 5 and a 5 here. We know that 5 over 5 is 1. We cross them off and just write 1. Let's see, we have 5 up here. Well, we have a 5 right here. So that means 5 over 5. That means what, William? 1. Right, it means 1. So cross them out, you got 1. So our brand new equation is 1 times 1 times 1 times 3. I know I have a magical voice, but no dancing. Then we have 2 times 1 times 1 times 1 times 2. What would our new reduced fraction be? I got 2 people know, 3 people know. What's 1 times 1 times 1 times 3? What's 2 times 1 times 1 times 1 times 2? I got 4 people that know. 5, 6. 7. I'll wait. I want to make sure everyone gets it before I just call on somebody. Take your time. If you got it, make sure you keep your hand raised so I know you're done. London's got it. Asia's got it. We're at like 64%. Get ready to say it out loud in 3, in 2, in 1, go.
3 fourths.
One more time, nice and loud. 3, 2, 1, go. Try it one more time without the silliness. You gotta be louder and prouder. I can only hear this side of the room. Really concerned about this side of the room. Ready? 3, 2, 1, go.
3 fourths.
There you go. 3 fourths. That is our reduced fraction going off of prime factorization. Now, for your homework and for your exit ticket, you have to do it this way. Because this is the whole lesson. So you got to make sure that you're doing it this way. Any questions on any of the steps? Kingston.
If there are 3 twos, why?
Ooh, that's a good question. Did we miss something? So 2 times 2 times 5 times 2 times 5 times 2. Ooh, there is a mystery. What should we do? Did we forget a 2 up here? Did we forget something down here? I don't know. Hopefully someone here was doing all the work. I did all the work on the board. That's all gone. Did anyone copy down the math that we did? London, you did it all? Copied it all down? You did? Wait, yes or no? Yes? I can't understand you if anybody asks. You did? Awesome. I'm going to give you 30 payments. So, Kingston? Well, actually, you know what? We could actually do the check. We could actually just look at what the book has to say. We did forget to multiply the 2, didn't we? So we have, it should not be 3 fourths, but instead, what should it be, Destiny? What? Thank you. All of you are so quiet naturally, and you're all wearing masks. So please make sure you're speaking up because I can't really hear you if you don't speak like a normal person. If you speak like a whisper, I cannot hear you at all. So our answer is actually 3/8. One of the best things you can do to maybe help you out, which we did not do, is rewriting them in order that you don't make those mistakes. 3 times 5s, 2 times 2 times 2 times 5s. That'll be very useful in your steps. Any questions? Kingston?
So we're supposed to write them in order.
Least to greatest. With the time. Because see what happened when we didn't, right? We forgot it too. Or if you're at Chess, he probably just says, Mr. Seaver forgot it. But rewriting it would be a very helpful step, so make sure that you don't make that same mistake we did in class. Asia? At some point you need a whole number? That's a good question. Would there ever be a time when you need a whole number? Probably not, honey. The only time you would get a whole number is if somehow you can get this just to 1. And oftentimes you will not get this to 1. Because usually when you do these, and on your exit ticket as well, answer on this is going to be the deduction. Because you're not following along, you're doing something weird with your book. Usually it would have to be the top one, but none of your exit ticket or your homework will have that. There'll be a small numerator over a larger denominator, and you got to list out the prime factorizations, cross out the ones they have in common, and you're good to go. Any other questions? That one actually took up a little bit too much time, and I want to give you time for your exit ticket. Before you start your exit ticket, you have to stop and listen because you're not going to do all of them because this takes a little bit. I'm going to have you cross them out, so don't start right away. Capiche? All right. Any questions? If you, Reese? You good? Okay. If you need to, raise your hand and I'll talk to you privately. Kingston?
So, would we still be able to use this as a fraction for the problem?
Yes. And in those cases,